Hello everybody, this is Stephen Whitfield with Drilling Contractor, and I'm here at the HMH facility in Houston, Texas. Now we are shooting this video during the Offshore Technology Conference, one of the largest conferences in the industry. The conference provides an opportunity for companies such as HMH to bring numerous visitors, clients out to their facility to see all of their really cool technologies that they've got going on. Now, this is an old annular BOP from 1952. This is not one of the new technologies that they are showcasing, but they've showcased a lot of really cool ones. So I'm here with Juan Benedetti of HMH, and he's going to tell us a little bit about what we're doing here. So Juan, can you tell us a little bit about this innovation showcase? What was it?
First of all, thank you for coming to visit our facilities. We're really proud to host you here. Very excited to have you here. So the Innovation Showcase is the perfect opportunity to host our customers to come over, have one-to-one time, spending time with them to talk about our operations with them, and also to showcase our newest and greatest technologies. And well, we're very excited to show you those technologies as well.
So we're going to take a look in this video at a few of the many technologies that you had out here. Can you show us or tell us the ones that we're going to see here today?
Sure. We're going to spend time showcasing three particular pieces of technology that I'm sure you will have fun to look at. Well, we're going to spend some time talking about the electric BOP that we're currently working on. We're also going to spend some time taking you to a simulator room where we are showcasing digitalization and automation solutions that are currently being used in a few semis, drill ships, platforms, and jackups offshore. And finally, we're going to take you around to the back of this facility to showcase our BD-120 Iron Roughneck, which is focused for land and it's fully automated as well.
So Juan, that sounds very neat. Let's check out the technology. I'm with Mark Taggart, and we are standing in front of a really cool piece of machinery right here, the Bulldog BD-120 Iron Roughneck. Mark was just giving us a little demonstration, and he's going to talk to us a little bit about some of these capabilities and design within this Iron Roughneck. So Mark, thank you so much for joining me here.
You're most welcome. I love talking about this tool. Very, very excited.
Well, you know, one thing that you did, you pressed the button and the thing started working.
Yeah, it's a fully
really
automated
cool.
tool.
Yeah,
The driller holds one button down, gets the pipe or the wrench on the pipe, and hits start, and he can put his hands back on the drawworks controls and just watch the wrench do the work.
What enables the automation within this Iron Roughneck?
Lots and lots of sensors throughout the whole machine, lots and lots of experience on the programming team putting that all together, but trying to mimic the actual process that a human would do on the rig, and using a tool to do it. Not fully autonomous, but using a tool to do that job.
So there are also some different design components that you guys were talking about off camera here. Can you tell us a little bit about some of those?
Our tongs here, they're a fully enclosed tong. So when this closes, it wraps right around the pipe. And what that does is it spreads the force, the clamping force that you have to put on the pipe to torque it up. It spreads that all around the pipe. It doesn't deform the pipe like other units does. So when you thread that tool joint together, that torque is actually going into the tool joint, not just trying to undeform the pipe that was squashed.
There's a huge safety element when we come to automating tools like this and getting people sort of out of harm's way. Can you talk about that a little bit?
Very much so. So most of the injuries that happen on a rig floor are right around the rotating zone. They have to do with making out pipe, breaking out pipe, moving pipe from hole center into the racking boards. This tool eliminates a lot of those because you're using a piece of machinery to make up that pipe. The roughnecks are standing off to the side. The driller is the one that's running this tool when it's operating. The roughnecks are just watching this machine do the job that they used to do.
Just standing off out of harm's way.
Just standing there having a coffee.
Oh, having a coffee maybe, yeah, a little bit. So there's also a cloud component. You have all the sensors that are within this system. You have a lot of data coming from them, and they're going into a cloud platform. What's sort of the importance of that platform?
Well, it gives the driller, the drilling company, the ability to hand to the E&P company a complete list of all the tubulars that went down hole, how much torque that they all saw, how it all performed. If there's a problem down hole, they can go back and look at those torque logs. You can look through the whole data string, understand the performance of the machine, understand where it can be improved, understand where your drilling performance can be improved, and just optimize everything to make the job go that much quicker.
I guess you can't have too much information, can
Well,
you?
that's the thing. Everybody loves data now. So we're grabbing as much data we can and we put it in the cloud and then we look at it and try and figure out what data actually matters.
Oh, that's really cool. Well, Mark, thank you again for taking the time to speak with us.
Thank you.
So we are here in probably one of the coolest rooms I've seen in a while. We're here in front of the simulator here at HMH, and I'm with Kai Kostel, and he's going to tell us a little bit about what we're seeing here behind us and some of the benefits that we see with automation and digitalization through some of the different tools and products that they have here. So Kai, thank you so much for joining me.
Thank you.
So let's talk about, there were 5 different products connected with this simulator that sort of highlight the benefits of automation and digitalization. And I want to go through each of them as you described them to us earlier here. One of them is this Drill View Go. Can you tell us a little bit about that and how it sort of works around situational awareness?
So Drill View Go is the HMI system of the next generation. It's the latest HMI system, and the whole idea is to have contextualized information and providing situational awareness for the operators. In existing HMI systems, there are so much information and it's fragmented, but here it's collected and put in correct order, and the focus is on well control and making sure that the driller is in control of the most important values that he needs to watch for his daily operations, while having supporting systems that gives him the full understanding of the situation.
And now there's also the Driller's Assist. Can you tell us about that?
Yeah, so Driller's Assist is an application that runs on the actual rig in terms of it controls machines. So it's for well protection, basically. It means that you can put into the system either feed automatically from a third party through integrations, or static parameters for how fast you want to run in, pull out of the well, how much pressure will you allow the pumps to put on your well bore. You have mud flow protection, hook load protection, etc. So it's about protection and well protection limits, and the whole purpose is of course to eliminate NPT in the well construction phase because of errors or mistakes.
So now we also have to automate sequences, and we do that through the CADs. So can you tell us a little bit about that?
Yeah, so that is for supplying consistency on the surface or topside level. So CADs is an engine that basically runs the topside machines according to a pre-programmed best practice. So it enables automatic tripping in, tripping out, drilling connection. And instead of the driller and assistant driller or roughneck spending a lot of mental capacity on moving machines to optimum performance, the system is doing it for them. So they can take one step back, monitor, see how things are moving, having a much better situation awareness, not focusing on those micro things of moving machines. I hit confirm, system takes care of the rest. So what's happening now is that the drawwork will start hoisting the top drive up to upper working point. That would be normally done by the driller's chair. Here we can see the hydraulic roughneck moving in, positioning on the stick up, preparing for connection. We see the pipe handling system getting into the fingerboards, gripping the pipe, moving it over to well center. So this would be 18 to 20 different commands made by these two operators to trip in one stand in manual mode. So imagine tripping in 15,000 feet. We are talking 3,000 commands executed in perfect order.
Well, now we talk about the automated component of this, but then we also get into the digitalization part too here, and sort of seeing where we are in the well. So you got the well map and the e-tally. Can you tell us first about the well map?
So what we see when we are visiting rigs is that there is a huge need of visualization. So in the company man's office, in the driller's cabin, in the tool pusher office, they all draw these wells on their whiteboards, and they note up all these key values that we need to remember. And same onshore on the support centers. And of course, none of these whiteboards are synchronized. So they are all living their own lives and their own revisions with different updates on them. So there is a value in making that as a digitalized solution, a digital well. First of all, it provides a common truth to everybody. And second of all, when you all work in the same environment, you're adding value to that. One of the benefits is also that this solution will be transparent offshore, onshore. So you can sit on your onshore operation centers and see exactly the same data and the same truth as you are doing on board the rig.
Well, that's really cool. And when I get into the e-tally, so tell us a little bit about that.
So it's an electronic tally system, and it takes care of both the logistics part of it, the onboarding of the pipe, the planning of the pipe, and the actual execution, making running tallies, etc. So when you think of the manual process, all those steps that this pipe has to proceed through pipe deck, through measurement, through pickup list, it's manual, it's noting down, it's making Excel files, etc., etc. Putting all this into a digitalized system removes manual errors, as we know that there are quite a lot of. And it also adds a lot of value by having this data already in. So you can make your all your running tallies, all your upcoming operations is planned digitally, and it's fully visible in all of the surfaces that we have been exploring here today. Even onshore, you will have very accurate bit depth readings in all situations. So it just adds so much more value to the rest of the offerings that we have.
Taking all these processes that you would write down on pieces of paper, I guess, and then taking them, digitalizing them, that's got to be such a valuable functionality.
It's a very valuable functionality, and it creates a more transparent environment for these people. So if there is a pipe that has a poor condition, or if that pipe has been in the hole rotating for 250 hours, the system will tell you that now you have reached the threshold of rotating hours. Remember to put this away when you are on the way out of the well. So it adds up with so much more functionality.
Okay, so I'm here in the chair. What are we going to do?
We're going to trip in some pipes. Are you ready?
Let's do it.
All right. So here we have an automized system, so there isn't much you need to do other than select from the menu. You can trip in, trip out, do drilling, etc.
I think I'll trip in.
Perfect. Hit the button, and then it's asking you to confirm your settings. You can hit the start at the bottom.
We'll do that.
Verify that there are no people out on drill floor.
I don't see any people.
Good.
So we'll confirm
that. All right. Sit back, relax. So what will happen now is that the pipe handling system is preparing the stand, is asking you to do a verification check in the start. So verify that the slips is open. And we have verified, yes, my slips is open. Continue, and then we go.
Look at that.
So now we are running in hole to the lower working point. Your next stand is ready in the pipe handling system. We are lowering with the reduced speed because in here we will have a driller's assist protection system. So this is as fast as you are allowed to move in this part of the well. Closing the slips, it will set off the weight, open up the elevator. So all you need to do is to either use this button or the continue button on your left-hand chair. Now it's asking you to verify that the elevator has opened.
Okay, so can I just press this button right here?
Just press it. Yep, very good. So once you've done that, the system will proceed, going back up to upper working point, and it will prepare for connection at the drill floor.
All right.
So now it's stabbing in, and then it's asking you to verify that the stab was done in a proper manner. If you're happy, you can just hit continue again.
All right.
It's also asking you to verify that the elevation of the top drive is okay according to the stand.
Verify elevator height. Okay.
If you're good, you'll hit continue. And that is the 3 steps you need to do in order to trip in a stand. The 3 confirmations.
Wow.
Other than that, it's all running fully automatic.
That's so easy. Just a few buttons to press. Well, Kai, thank you for showing us around here and giving me a chance to take a look at this simulator itself. I mean, this is some really cool technology. We appreciate it.
Yeah, you're very welcome.
Okay, we are here with Brian Piccolo of HMH, and he's going to be talking to us about the electric BOP. Now, they won't let us film it. We got a prototype off here on the facility somewhere. We've got a picture of it behind us, though, and we're going to hear a lot of cool stuff about it. So, Brian, thank you so much for joining me today.
Sure.
So, let's talk about the electric actuator on this BOP. Can you tell me a little bit about it? Tell me about some of the functionality.
Yeah, so the electric shear ram actuator that we're talking about today is equivalent in terms of its force capacity to the existing 22-inch 5K bonnets that are operating in the field today. It also fits within the same space envelope. It's just as compact. You're able to open and close the bonnet doors just as you would. Same force, and some added benefits are that it is able to shear in just 12 seconds.
So I did get a chance to actually take a look at the actuator a little bit earlier, and one of the things that we pointed out to us is how there are a lot of tried and true components within this BOP, and how sort of the familiarity that a user might have with some of these components might provide a benefit. Can you talk about some of that benefit?
Yeah, absolutely. The foundation to our electrification program is to ensure that we're building these systems from proven components. So if you look at it from the well control side, the wellbore wetted components like the BOP body, the cutting technology, the sealing technology, all of those components that the industry is already familiar with are staying exactly the same. The same is also true for key components in the surface and subsea control system as well. But what is changing is that we're mapping those components to a motor and drive technology from the transportation industry and a drivetrain from the mining industry. There, we're also using proven components, but where those synergies exist, we're incorporating them into our system.
Brian, thanks for telling us all about this. We appreciate it. Wow, Juan, you know, that was actually really cool to see all of that technology, the simulator, the electric BOP, the iron roughneck, all this really cool automation stuff. Thank you so much for letting us come to your facility and see all that.
No, it is our pleasure, and I must say, it was quite fun to see you become a driller as well.
Well, maybe I'm not giving up my day job just yet, but that was a really cool thing to do, so thanks again.
Thank you for coming.
And thank you for visiting drillingcontractor.org.